basically everything that we did in our last College Board module was pretty much all of Unit 3, but we do have a little bit to kind of add in that wasn't covered. So we used properties of exponents a little bit. We're going to approach those a little bit in more detail now, and we did add, subtract, and multiply polynomial expressions. So that I'm going to just kind of touch on, but not do a whole lot with. But what we haven't done is division. We haven't done what's called synthetic division or long division. And so we're going to learn about those three types of division here. And notice how the first one is by a monomial, meaning one term, versus the next two, which is binomials, two terms. So our first thing that we need to know is any term with an exponent of 0 is equal to 1. So the thing that you need to remember is that this right here, this 0, is only attached to the x, not to the 5. So really, this is 5 times 1, which is 5. Over here, however, this 0, everything is raised to the 0 power. So since it's all to the 0 power, it just becomes a 1 altogether. The whole thing becomes 1. Anytime that you have a negative exponent, it switches from numerator to denominator or vice versa, and then becomes a positive exponent. So again, the only thing that's attached, in this case, the x is the only thing with a negative exponent. So all that does is it comes up to the top of your fraction, and it would make it 1x cubed, which is just x cubed, and then the 2 stays in the bottom. And then over here, we only have our x to the negative second here. That's the only one with a negative exponent. 32 has its own, and y has its own. So this is going to come down here with the 5 to give you the answer of 32y over 5x squared. And these are all considered simplified because we don't want negative exponents. We always want positives. Okay, so when we get into the division, one thing that you need to know is when they have the same base meaning x or y or whatever, you just subtract your exponents. So you put your quote-unquote leftovers in the same place as the term with the highest exponent. So let's start with 45 divided by 9. Well, 45 divided by 9 is 6. And 45 is the bigger number. And so when we divide them, 6 goes up top. So if you want, you can use arrows to help remind you of where things go. Now x and x to the 5th. So same base, subtract your exponents. This would be x to the 4th because it's 5 minus 1. And it goes up top because that's where the higher exponent is. And then we have y squared and y to the 6th. Now this one's going to come down here. 6 minus 2 is 4, so that's y to the 4th. And so your denominator is y to the 4th, and there's your answer. Okay, so first we're going to divide by a monomial, meaning one term. And now granted, there's a 4cdf cubed, but there's no plus or minus, which makes it one term, just one big term. So what we're going to do is separate each term in the numerator to be divided by whatever your divisor is, and then simplify each thing individually. So let me go and scroll down so we have a little space here. So basically, this division sign means there's your divisor right here. So I'm going to take 20c to the 4th d squared f, and I'm going to put that over 4c df cubed minus 16c df squared, also over 4c df cubed, and then plus 4c df cubed over 4c df cubed. All right, so then we start our division process. 20 divided by 4 is 5, and it's going to go on the top because that's where the higher number is. C to the 4th and c, so subtract them gives you c cubed, and that's going to go on top because that's where the higher exponent is. D squared over d, 2 minus 1 is 1, so that would give you d on the top because that's where the higher exponent is. And then f over f cubed, so we're going this way to give you 3 minus 1, which is 2, so f squared, and it goes in the bottom because that's where your higher exponent is. So there's your first term, minus. Now, same thing here, so 16 divided by 4 is 4, and that goes up top because 16 is bigger. C over c, that's a 1, so it doesn't matter where you put it. D over d is also a 1, so it doesn't matter where you put that. And then f squared over f cubed goes on the bottom. Remember, subtract your exponents, so it's f to the first power, which is just f. And everything else was a 1, which means it was just being multiplied by 1. So there's your middle term. There's nothing more to do with that. And then here we get 1, and then a 1, and then a 1, and then a 1. So everything canceled out. However, it's not a 0 because we're dividing. So we would write here plus 1. And then that right there would be your final answer. All right, now your second example, it may look like this, and that's all good. So all you're going to do is just split it up, 6k squared m over 2km squared minus 12k cubed m squared over 2km squared, and then plus 9m cubed over 2km squared. And then again, just go through your division process. 6 divided by 2 is 3, and 6 is on the top, so it's going to go up top. K squared over k is k. Again, higher exponent, so it goes on top. And then m over m squared, subtract them, higher exponents on the bottom, so it goes in the bottom. Minus 12 divided by 2 is 6. 6 goes where the 12 is because it's the higher number. K to the third over k is k squared, goes on top because that's where the higher number is, and then m squared over m squared is a 1. So your denominator is a 1 because everything moved to the top. Okay? And then our last answer here, 9 and 2 are not divisible, so we leave 9 over 2. K doesn't go into anything, and then m cubed over m squared moves up to give you m. So your final answer is 3k over m minus 6k squared plus 9m over 2k. And that's your final answer for this problem. All right, our next type is using long division, and this one is a little bit complicated if you don't really remember how to do long division from elementary school. But the first thing is that anytime you see this little -1 exponent, that just means you're dividing by whatever's in the parentheses. So really, this right here is just saying x to the 5th minus 4x cubed plus 4x squared divided by x minus 4. All right, so we're going to have to pull on your long division skills a little because it's probably been a while. But remember, this is your, whoa, that looks terrible, so let's try that again. That's your division bar, and we're going to put x minus 4 out here because that's what we're dividing by. Then on the inside, notice how it skips from 5th power. There's no 4th power. There's a 3rd, a 2nd. There's no 1st. There's no constant. We need a spot for everything. So we need to put x to the 5th in here. And then we're going to put in a plus 0x to the 4th because we don't have a 4th power. Minus 4x cubed plus 4x squared. And then we're going to do plus 0x because there is no x term, and then plus 0 because there is no constant term. So we need a placeholder for everything. So then from here, what you do is you ask yourself, what do you need to multiply x by in order to get x to the 5th? Well, using the the rules of exponents, x to the 4th times x is x to the 5th. So once you've decided what that number is, or what that variable is in this case, you're going to take this number, multiply it by x, and also multiply it by a minus 4. And you're subtracting. So x to the 4th times x is x to the 5th. And then x to the 4th times a negative 4x to the 4th is negative 4x. Times negative 4 is negative 4x to the 4th. Now remember, you're subtracting, so if you change this to an addition, this becomes negative and this becomes positive. And then you add together. Every time that you're going through this process, your first term here should be a 0, which it is. X to the 5th minus x to the 5th is 0. And then add these together. 4x to the 4th. Drop this one down, negative 4x cubed. All right, so again, what do you multiply x by in order to get 4x to the 4th? Well, that would be plus 4x cubed. So then we go through. 4x cubed times x is 4x to the 4th, and then 4x cubed times a negative 4 is a negative 16x cubed. Again, change this to a plus, minus, plus. So everything's changing signs. This becomes a 0, and this becomes 12x cubed. Then we go ahead and drop down our 4x squared. And so now same thing. So I'm going to go ahead and x times 12x squared would give us this term here. So plus 12x squared. So multiply it through. Get 12x cubed minus 48x squared. And moving along, so we are going to change that to an addition, change, 0, and then this is a 52x squared. And then again, drop down your 0x, so plus 0x, and that would make this x times 52x would give you that number here. Multiply it through, so 52x squared, and then this would be a minus 208x. All right, and then that makes this a positive, negative, positive. That's a 0. This is a positive 208x. And we drop down our constant term of 0, so plus 0, which comes all the way from here, all the way down. And then same with that last one right there, that's coming from all the way up there. And this is coming all the way down. All right. Drop it down. All right, and then so x times 208 would give us 208x. So here and here is what we're looking at. So plus 208. Multiply that through, and 208x. And then when you multiply the 208 by the minus 4 up there, you get a negative 832. But again, we're subtracting this whole thing, so change all the signs. That's a 0. This is 832. All right, so that's what we call your remainder. And so here's how you're going to write out your final answer. So all these numbers up here is part of your answer, and then as your remainder, since it's a positive number, you do plus 832 over this right here we were dividing by, x minus 4. And so your final answer for all that crazy work is right there. I know it's really crazy and long and convoluted. We'll practice a lot when you get into class, I promise. All right, so I'm going to actually skip this second example, and I'm going to go right into synthetic division, just so you can get it done and not have a whole second video to watch. All right, so in this one, using synthetic, it gives you just kind of a shorter process on how to get to your final answer. Basically, the first step is that you have to know what the 0 is for your whatever you're dividing by, and then once you have that, it's just a matter of doing it over and over. So it's too much to put into words. It's kind of like long division, where it's just a lot and you just have to see it and do it. So I'm actually going to skip this one, and I'm going to give you this example instead. So if y minus 1 is the factor, then that means 1 is your actual 0. So we put 1, and we put this little kind of box thing around it here. We need a spot then for y cubed, for y squared, for y, and for your constant term. In this case, the coefficient for your y cubed is 1, y squared, we don't have it, y, we don't have it, and constant is negative 6. And now it's just a cyclical process. So what you do is drop your first one down always. You take this one and multiply it by the number in the box and write that here. Add them together. Take this number, multiply it by the number in the box, write it here. Add these two together. Take this number, multiply it by the number in the box, write that here. Add them together. Then when you go to write your final answer, whatever your beginning started with in your problem, your answer is going to start with 1 less. So since this was y cubed, this will be y squared, y, constant, and remainder. So your final answer then is y squared plus y plus 1 minus 5 over what you were dividing by, which was y minus 1, because it's your remainder. All right, so there you go. So just remember that this is just one big cycle. So you take this, multiply it, write that number here. add, or I'm sorry, here, add them and just keep on going through the cycle.